Welcome back to the shop. It's good to see you all again. And in this episode, I ask a very simple question. Is this the best CNC router bed money can't buy? Let's have a look. Let me explain what I'm trying to do here. This router came with a truly awful bed. It was aluminium extrusions and with T-slots. It was difficult to use. It was quite thick, had a thicker plastic layer on the top which got chewed up regularly and was compressible, so when you bolted things down to the table, if you over tightened them you could actually push them into the surface. It was dreadful. So I've taken it off and put my own on. This is made out of birch ply and should have a safety feature built in so that if the tool touches any of the metal or grinds its way into the table far enough, it will automatically stop the machine. So let's see if that works. Before we get stuck into that, I've had mail. So let's just have a quick look. Ooh. You choose to do an unboxing video with the hardest to get in parcel you've ever come across. There we go. Oh. Ooh. Look at those. Hey. Yep, I've had some stickers made. Let me just add something. I'm off to the Midlands Model Engineering Show on Thursday the 17th of October at the Warwickshire Event Centre. I will put the details down in the description. If you fancy one of these, say hello to me if you see me walking around and I'll give you one. So I'm just going as a punter. I'm not a guest or anything like that. I'm just there to buy a few bits and pieces. So if you see me, say hello. It'd be good to see a few people, if any of you turn up. Anyway, hope to see you there. And free stickers. Who doesn't want a free sticker? I'm back in the control panel, and this is the VFD. It's not very sturdy, is it? It never came with a shroud. But that's all right because there's no shrouds over these supplies anyway, so yeah, it's easy to kill yourself in here. There is no opportunity to put an external braking resistor on this VFD. It just doesn't have that wiring. So I've been through the menus and you do this to get into the menus. Oh. There we go, and then you can select which menu you want to look at, press enter, and it tells you what the factory setting is, and you can alter it up and down here. So there we go. And also you can look at the output current, the output voltage and the frequency. So if I turn on the supply, turn on the motor, we're running at 350 Hertz. You can hear the motor is fired up. If I go along, that's taking 1 amp, and that's the effective voltage that's going to it. So let's turn that off. There we go, and that's dropped to 0. I've set the maximum braking percentage that I can do, and also set it to decelerate in 2 seconds. I put that down to ½ a second and it didn't like it, so it tripped out. So that's as far as I can go with that. So next up, if I tilt down, there we go. This is the Rich Auto control system, and I've temporarily hooked a cable up to pin X7, which is the emergency stop. The emergency stop that's on this control panel, all it does is turn the power off to the whole unit. So I've got my multimeter here. Can you see that? There you go. There's my multimeter. And there's the end of the cable. I've hooked on here to the ground output from the cabinet, and so if I hook onto that cable, I get 12 volts. Don't know if you can see that. There you go, there's 12 volts. This is an active low break. So if you take this to ground, it should automatically break. It should say there's a fault condition and stop. So let's turn the motor on and give that a go. If I ground that out, we'll see whether or not it works. I haven't tried this, I've no idea. There you go. Alarm. It's brought off an alarm. So if I press OK, we should be back to normal. There we go. Excellent. Right, so the next thing to do is to try that out on the actual machine. 1, 2, 3, 1, 2, 3. Right, so this is stage 2. If I, hopefully this works, if I touch this e-stop wire onto the rotating spindle, I'm hoping that it stops. And it doesn't. Well, that's interesting. It did there on the body of the motor, but not on the spindle. There's some building work going on next door, so you might not hear this very well, but there we go. So let's have a look between those two. All right, there is decent continuity. 0.003 of an ohm. Here's the other way of testing it. I've grounded out one test lead on the frame of the machine, and the other one is connected to that control cable. So, and we're registering 12 volts. So if I connect to there, it definitely drops to 0. Touch it on. Right. That's my fault. I suspect that touching the cable on the threaded section was making an intermittent connection. So just doing it inside the taper seemed to cause it to stop. That's good news. We can use that to our advantage here. Let me try and illustrate what I want to do with the table on that router. The table as it is rubbish. It's difficult to use. The plastic layer on top gets chewed up left, right and centre. So I'm going to take the aluminium extrusion and the plastic rubbery stuff off the top and replace it with 2 layers of 12mm ply. First up, I'm going to put 1 layer of board on. Then I'm going to cover that with this aluminium foil, and over the aluminium foil I'm going to bond another layer, and the two are going to be held together with glue and these threaded M6 inserts, which will go clean through the top and into the bottom. They're going to be my anchor points. So there will be, I've got lots of these, in fact I bought 100, so there'll be every, so far, in the on the surface. All you'll see on the surface are these metal inserts and holes. And if your cutter, here we go, this is the other crucial bit of information, that signal wire, that auto emergency stop wire, will be connected to that aluminium layer. And also, because these threaded inserts are going to penetrate that, hopefully they'll be connected as well. So if your cutter comes along and it touches one of these inserts, it will trigger an e-stop. Also, if something goes dramatically wrong and the cutter cuts through and into that foil layer, it will again hit the e-stop. So before any significant damage has happened, the machine will stop. That's the theory. Let's strip off the old bed and get stuck in. I used this sharpened pencil to mark the original mounting holes where the aluminium slats were, so I can reuse them. I also marked the position of where these apertures are, so that in the future, if I decided to, I could make a vacuum table, because there's enough space under there to get a small cavity under each of those holes. You can see how the two layers are going to work here. This is the underside, and the small holes that you see here line up with the bigger holes the other side, so that the mounting screws will be countersunk and embedded in the surface. You'll see that in a minute when I screw it back together again. I decided that the most accurate way of putting most of these holes in was to do it with the CNC itself. So here we go, and I use this thing called a compression cutter. It pushes the chips into the middle of the cut, so you end up with a clean top and bottom edge. They're very useful cutters, those. The router couldn't make the outside row of holes because it can't reach them, so I had to mark them and do them by hand. They don't need to be that accurate because they're only hold down screw holes for those M6 threaded inserts. You can also see here that the slightly larger holes are for the M6 inserts. The smaller ones are actually for the alignment dowel pins. All of these holes are actually designed to not penetrate all the way through the bed, because I didn't want the chips that this machine produces to actually fall through and underneath and onto the lead screw and just get in the way, basically, because they're difficult to clean from underneath. So I made that little jig to stop the drill from penetrating. Right, you probably saw on the time lapse, a bloody wasp stung me, little sod. Anyway, that's swelling up nicely. Fully covered. This will be, when that layer goes on top, this will be sandwiched inside the bed. So let's check to see whether or not it works. So got my little meter. And in theory, if I go corner to corner, that should beep. Spot on. That corner to that corner. That means anywhere in here this is a whole electrically conductive plane. Excellent. So what I'm going to do is put this piece to one side and do exactly the same with the other piece. There we go, and I've taken out all of the screwing down holes. So we should be able to just put the top straight on. Come on in, up you come. Come on. Too far? Come here then. Let's put you up there. Look, there you go. You've got sweethearts all over you. Right, hopefully this should hold the 26 it. So the clamps should hold these top and bottom together long enough or tight enough for me to get these threaded inserts threaded in, and I will just show you what we've got inside these. You hopefully can see in the bottom of that hole is the aluminium foil. So when this insert penetrates that foil, it should, excuse the dodgy camera work, it should actually make a reasonable connection with it. So the only thing to do is screw it in and try it. There we go. Okay, let's try the meter and see whether or not we've got a connection. It's not the end of the world if it doesn't work, but it'd be nice if it did. Oh, there you go. So you're saying, what does that mean? Well, it means this. If you're using, this is a hold down bolt socket basically. So if your cutter, represented by this, comes along and touches this, it will automatically stop the machine. It'll go into e-stop. So that, to me, strikes me as being a bloody sight better than what I've done in the past, which is chew up clamps like they're going out of fashion. Excellent. I need to put the rest of these in, which I'll do off camera because it's dull. And then we'll put this bed back on the machine.
I added this little die-cast box years ago, and it's just got inside hookup cables from the main CNC control box. I drilled a hole through the top. I couldn't find a grommet, so I used 2 or 3 sections or 2 or 3 different diameters of heat shrink over the wire as it exits the hole, so that should protect it enough. And this is a baffle board. It was a simple attempt to try and contain some of the chips that this thing generates. So here we go, a little bit of testing. Home the machine, then take this trapped wire which is connected to that isolated sheet of aluminium between the layers of the bed, and there you go, it's gone into e-stop. Perfect. This was the sketchiest piece in the whole operation. I was petrified of doing this. It's quite heavy, 300 odd kilos apparently, and suspended on a couple of ratchet straps. Didn't strike me as being very good, but yeah, I'll leave you with this and just put some music over the top of it because it's embarrassing. Well, who'd have guessed after all that shenanigans it still works. Right, here we go. This is the acid test. I'm going to try and run over this this hold down clamp and see whether or not it e-stops. I say that was a no. Should have e-stopped there. Yeah, I'd definitely put that down as a no. There you go though. It does work as long as the spindle's not rotating.
Thanks for joining me in the shop today. It's muchly appreciated. So back to my original question: is this the best router table out there that money can't buy? And I think the answer is no. However, I'll qualify that. I think it's no at the moment. This is what I think is happening. When you run the spindle into a piece of metal on the table on this router bed, it stops instantly, absolutely spot on. And you've seen you get a display on the pendant saying e-stop has been hit. It stopped, perfect. However, when it's trying to do that as a cut, so if the spindle is rotating, then effectively you've got it's making connection, leaving a gap, making another connection. So it's a digital square wave, and I think there's noise all over this as well because the spindle motor is running. So and the power for that all comes down the same loops. So effectively, there's noise, electrical noise. Also, I think the actual control system in this router is polling the e-stop pin. So if you can imagine, as the program goes through lines of code, it gets to a line of code that says, look at the pin to see if there's been an e-stop triggered, and it'll look at it briefly, and then it'll go off and carry on cycling around this code. So my guess is that it's only looking at that pin every few milliseconds, which means that if you've got an intermittent cut, so it's intermittently making connection, and it's only polling it every now and again, you have to wait for those two signals to coincide so that it's triggered the e-stop at the point where it's actually polling the pin. So I think that makes it a little bit less reliable when you're running the spindle. However, that's not the end of the case, because I think it's not that difficult to build a little interface. It could be as simple as a relay so that when you've triggered an e-stop, it crowbars that pin, the e-stop pin, to ground and holds it there, so that it doesn't matter if there's noise or electrical intermittency coming from the actual machine. The control system will know next time it polls it, it'll stop. So I think that's the way forward. So I think it could be the world's best CNC router table, but I need to make that little interface. Anyway, sorry for the ramble there. Hopefully that makes sense. I think that's what's going on, but I can't prove it because I haven't got my scope. I lent it to a mate and 3 months ago, and then he went off to work on the Olympics, and I haven't seen him since. So there you go. I'll get that back at some point. More to the point, thanks for joining me, and we'll see you next time. Take care, stay safe.